I'm gonna repair a half gray JPEG photo, and I will just record what I'm doing and see if I will do something with the video later. Here's the photo. So there you have it. It's the JPEG Repair JAN new folder. Go away. Start JPEG Repair. Select patch. Go to JPEG Repair. And this is the file. Now, so the image is half gray. It can mean a couple of things. It can simply mean the data is not there, in which case you cannot repair it. It can mean there is corrupt data, obviously, and at some point the decoder just gives up and stops decoding while the rest of the data is there. And there is one special condition, and that is normally the end of a JPEG file ends with a specific byte combination, FFD9, which is also the end of image marker. If data corrupts, it can become all sorts of values, and FFD9 is a value that could coincidentally occur. But this is rather rare. But say you we will now okay this, and we'll click repair. Now imagine that we still cannot get the rest of the file visible. Then one option is that it's interrupted by an end of image marker. And say your photos of the camera produced are like 3 MB, 3.2 MB, and this one is all of a sudden 700 kilobytes, then of course it's obvious that the file is simply too small and most of the data is missing. Normally I always start without this ticked. I've been considering if I should make this the default option, but it's rather rare, so this is not the default option. The default option is to assume the file is the FFD9 byte pair is simply the end of the file. So we have selected the file. Did I select the file? So I'll do it now. Then you click repair in the patch mode. Patch mode sounds like it. Okay. Now we can already see that there is data. So right up till the end of the file. So in this case, we do not need to reload with this this ignore end of file marker ticked. Now the first thing you want to do is see where the corrupt data starts, and you can watch the magnifier here, or if you keep the left mouse button pressed, the magnifier will snap to the cursor. So it's around here. Double click. Did it register? Yeah. Okay, now what you want to do is you set the spot where the corruption starts. The program takes this position in the image and figures out the byte address of the data which is associated with this particular part of the image. This is corrupt data, so that has to go. The red value is what will be removed, the green value is what will be added. we'll get to that part later, what will be added. So we're gonna remove data. Now start with a little bit. Okay, now I see something happen because I've seen it before. I have clicked too high. I will show the difference. We'll reset. So this is the image as we found it. Now if you look at where the corruption starts, and you look at, for instance, at this table. Now I'll start removing data. Plop. And you see that actually above where the original corruption is, we introduced a new line of corruption. So that means we clicked one line of MCUs too high, and an MCU is a block of pixels. Most of the time 8 pixels in height. So we could try to click again. What we can also do is drop down one line of MCUs, click apply, and now we hit the right spot. Now this is quite a lot of corrupt data. You can already see here that that's at least 5 lines of MCUs worth of corrupt data. So that means, since I don't want to keep this button pressed all the time, I'll increase the interval. So this will now jump 128 bytes each time. Now this is simply a matter of trial and error. People keep asking me, what numbers do I enter here? What number do I enter here? I don't know. You click here, then this position gets translated in the byte address, which is entered here. And I keep removing bytes until the photo looks better, until it's something I can do something with. So I don't know how many bytes we will need to remove. I'm just trying, just tinkering. And I'm working on a copy, so I mean, it's like Bob Ross says, every mistake is a happy little, what does he call it? It's not the end of the world if we don't get it right, we will just try again. Now we already see that this is looking better. Now, so now we'll, oh, you see this value is maxed out at 32,767, whatever you can see there. So what this means is that I'll have to save the file, load it again, and then continue where we left. Yeah, maybe. Well, yeah, okay, so we'll do that. So then I can show you that too. Save and reload. Means it will save the file and reload the file it saved so we can continue where we left. It decodes again. Okay, we'll have to do the same trick again. Remove a couple of bytes. See. I'm again too high. Okay. Oh, too much. Overwork. Now, it's a good idea once we get close to lower this value again. So whenever the value is higher than 1, it tries to snap to an MCU boundary, and if you set the value to 1, it will move 1 byte. Okay, this is tricky. because, or it's not tricky at all. We removed over 32,000 bytes, this and what we did before. So that means kind of you see here that this data is missing. So even in Photoshop this is hard to fix. So what you want to do is start adding bytes. Basically for every byte you remove, you add another byte to properly realign the image. All the bytes we removed here will show up here. I mean the image will get less high. How do you say that? So we can just click until we reach 32,000 and then we'll see what happens. And then we need to add a little more. So we do the same trick again as this is maxed out. Yeah. Now it's less of a thing where we click as these bytes we added already are all zero, so we can basically at any point add a bunch more. So same thing, we get closer and we'll lower that interval. So we have more control. Something weird is going on here. I was too high. I mean, I saw a line of MCUs being grouped there. So okay, this is nice. Now to go to this part, we'll have to save what we have. So in this photo, it's obvious that there are basically 3 corrupted areas. And the top one prevented the rest from being decoded. Okay, the same thing. We'll try to locate the start of the corruption. Double click there. See if we have the right location. Yeah, we do. And remove data. Oh, we can already see that. So bad bytes start here, corrupt bytes, and it continues here, and about here it stops. Because the JPEG file is decoded from left to first line of MCUs, second line of MCUs, third line, fourth line, etc., etc. So it goes from left to right and then drops one line left to right. So I was saying that there was quite a row of corrupt MCUs, so I don't have to be too careful immediately. Still corrupt bytes here, corrupt data. You see it collapse to the we're eating the corruption from this byte address we determined by clicking the image. Okay. There's still some corruption here. Almost. Okay, the same thing. We now need to add 0 bytes, stuff bytes, so we can move this part of the image to the right again, and we'll use the green value for that. And I always take one point that I can easily, from which I can easily tell, okay, now we've got the right position again. Sometimes you can also see here the right boundary of the image, so you can keep moving until you're there. But okay, you get the idea, I guess. Oh yeah. No. Oh yeah. No. Oh, we've gone too far. We've not. What's going on here? Okay, this is it. But now the color is on. And now we got the boot rate. So, and then for the next part. Now, sometimes I'm left with suppose that there's another line of corruption here. Then you can decide, okay, I'm not going to put a lot of effort in it because it's not important for the overall picture. So then you just export it to your photo editor and crop it and cut off the remaining corruption. We have to find the Z spot again. Here. This is a lot of corruption again, so I'll increase this value. Now if you watch closely, you can often already see, no, we're not too high, okay, so that's good. Or maybe I should show it. Reset. So let's say I click too high. Now you can already, often you can already see, you see another line popped up here. Another line above the original corruption, other line of corrupt, distorted MCUs. So then you know, okay, one line down and we'll have the right spot. Maybe we need to save and reload. Maybe 32,000 bytes is not enough. I'm gonna save and reload. I don't have to click again. I'm too high, you see? So double clicking the green value copies the red value over here. So then normally, like say you removed about 16,000 bytes and you double click it here, then you have about the value you're going to be ending up with. Most of the times you need to add more of those stuff bytes than this looks weird because we need to add an entire other line too. Well, and then the other thing we see, of course, is that this shift in color, if you move the position from which we add and remove bytes a little, then often you can play with the color. So I'm gonna add an entire line of MCUs, because you see at the bottom of the image that we removed many more, of course, and we're adding now. And but on the other hand, this is of course not a really very important part of the image. So with Photoshop you can get rid of weird stuff. What will I do? I will just and I keep mentioning Photoshop. I use a free tool most of the time, paint.net, so it's not like you have to go and get a Photoshop subscription. Okay, let's go with this. So, and then you end up with what we have, and these are all the photos we saved to get to this result. Now you can, the color in the back you can get it better, but with something like paint.net you reduce brightness a little and our luminosity, and then it will look the same. And the same with the same tool, you can get rid of those green lines, the bytes we stuffed in there. And so that's how you can fix a half gray JPEG file using JPEG Repair, assuming, like I said, that all this data is actually there. So in this case we see the file is 5.5 megabytes. So all the pictures from this camera will produce similar sized files. But it can be 4.52 and a little larger too. But if this file would actually be, let's say, 1/5 of the file size that the camera normally produces, then this missing data is obviously really missing, and then no tool can repair that. We cannot grab that data from thin air. Okay, we're done.